Hello everyone, this is Muhammad Hamza Javed, and in this video we'll be downloading and pre-processing a new dataset. In the next couple of videos we'll be building, training and testing our model for a classification problem. Later we are also going to leverage a pre-trained VGG16 model and try to fine-tune it. So I've opened my Jupyter notebook, and in this videos and next couple of videos I'll be teaching you what a convolutional neural network is, or covnet is. We'll discuss what is a convolution operation and MaxPooling operation. Next, we'll build, train and test our first ever covnet. Previously, we built a neural network, but that wasn't a convolutional neural network. This one is. Lastly, we'll leverage a pre-trained model called VGG16 and we'll try to fine-tune it. In the previous video, we learned what Keras is. We also built and trained and tested our first ever neural network. We also got some predictions from our model, and lastly we saved and loaded our model. In case you haven't watched that video, I highly encourage you to go back and watch that first, and then we can proceed. So assuming that you have already watched that video and all the required dependencies are installed, we can proceed. So in this video we'll download and pre-process the datasets, and that's all we are going to do in this video. We might also build an image data generator from Keras for generating our training batches. So the first thing we need to do is click this link and download our dataset. The dataset is going to be around 550 MBs. The link has taken me to Kaggle, and here under the data tab you would be able to find two zip files. The first one is test1.zip, the second one is train.zip, and we are interested in the train.zip file. Let's download this. I have previously downloaded this zip file, so I'm going to cancel the download and move back to our Jupyter notebook. So once the dataset is downloaded, what you need to do is, the next thing we'll be doing is moving the train.zip file to a directory that contains our Jupyter notebook. I've already done that, and here's my Jupyter notebook, and here you can see the train.zip file. The very next thing that you need to do is extract the train.zip file into a directory where your Jupyter notebook exists. So I've done that already. Let's rename this from train to dataset for our convenience. Let's move back to our Jupyter notebook. So here you can see I'm importing two modules. The first one is OS and the next one is shutils. Both of these modules are going to help us create new directories programmatically and copy the files from one directory to another. We'll call our original dataset directory dataset. It's the same directory that we just renamed. In this problem, we'll be classifying the images of cats and dogs, so we'll call our directory cats and dogs small. In this snippet, what we are doing is we are creating a new directory called cats and dogs small. Let me verify if the directory was created. Yes, here you can see the directory is created, but right now it's empty. In this block, we'll be creating the train directory with the same procedure. Now you can see there's a train directory over here. Further, in the same train directory, we'll be creating two other directories called cats and dogs. Let's run this. Let's move into the train directory, and here you can see we have got a cats directory and dogs directory. Both of these will be empty right now. Okay, before we run this block, let's move to our original dataset and see what the file names actually are. So I'm in my dataset directory. I want you to focus on the names of these files. These are cat.4.jpg, then there's this cat.5.jpg. So images are named this way. If I scroll a bit down, we would be able to see the images of dogs with the same naming convention. So as you can see, we have got an image of dog and it's named as dog.2835.jpg. Okay, so now let's move back to our code. So first of all, we'll be creating an array of file names. The rest of the file name will stay the same, only the number would be changing because we have used a list comprehension over here. Here we are copying the original file from the dataset directory to the cats directory within the train directory. Let's run this. We'll be doing the same for the dogs as well. We'll be copying them from the original dataset directory to the dogs directory within our train directory. Before we proceed, let's move back to our directory and make sure that the files are actually there. In the cats directory, I can see there are a couple of files now. These are 200 files. And same goes for the dogs directory. Now we have got 400 images. 200 of them are cats and the rest of 200 are dogs. So now it's time for preprocessing. For preprocessing, I'll be importing image data generator from tensorflow.keras.preprocessing.image. So in this line, we are creating an object for image data generator and we are passing rescale value as 1/255. In the previous video, we learned that our dataset should be scaled, so it's easier for our network to get trained on. Next, we'll be calling the flow from directory function on our train datagen object. In this function, we'll be passing a couple of parameters. The very first one is the path to our train directory. Next is color mode. We want all our images to be loaded as grayscale, which means black and white. The next is target size. Regardless of the size of image, our images would be loaded as 100 by 100 pixel images. The batch size is 200. I have deliberately kept it 200 because I want all our images to be loaded in one go. The next is class mod. Since we are dealing with a binary classification problem, either it's going to be a cat or it's going to be a dog. So I have passed binary over here. Let's run this. Okay, so it says that we have found 400 images belonging to two classes. Before we proceed, there's a caution. We need to install Pillow library. So what's Pillow? Pillow stands for Python Imaging Library. It adds image processing capabilities to our Python interpreter. Let me show you how you can install Pillow. I'll open my terminal. I'll activate my virtual environment by typing source.mhjenv bin activate. Over here, I'll be typing pip install Pillow. This command will install the Pillow library to your virtual environment, but I'm not going to do that because I have done it already. Let's move back to our Jupyter notebook. One thing I want you to understand is this train generator is a directory iterator type of object, which means that it's an iterator, and in each iteration this would return us a batch. We have already declared our batch size as 200, so we'll only do that once. So this train generator would return training data and training labels. If you watched the previous video, you would know the only thing we need for training a model is training data and training labels. This tells us that we have 200 images and each of the image is 100 by 100 in size, resolution. This one here tells us about the channels in the image. If it's 1, it means that we are dealing with grayscale images or black and white images. If we were dealing with colored images, this would have been 3 because of the RGB channels. This 200 is telling us that we have got exactly 200 labels which match exactly with our data points, which is 200. I really hope that you followed along, and if you didn't, I really encourage you to watch the video again, but this time try it yourself. In the next video, we'll be building a CNN model. At this point, you not only have your dataset downloaded, but also pre-processed. In the next video, we'll be leveraging the same dataset to build our model. So people, that's about it from this video. I hope you enjoyed this video and I hope you learned something new. In case you liked the video, please give it a thumbs up. And in case you think that the video taught you something new, please share it with your juniors and your peers. Also, if you want to see more similar videos, please subscribe. Thank you so much and I'll see you next time.